Okay, it is February 16th, 2017, and I am trying to fix a problem with a Star Rider. I'm assuming it's a problem with the CPU board, because when I go through the diagnostics, everything up to this point works, and then when I get to this disk search test, when I move the joystick or the steering mechanism, nothing happens, and I'm normally supposed to be able to move steering to select digits to search to, so it just seems like it locks up, and no matter what I do at this point, I can't proceed. It seems like the game locks up. So what I'm going to do to troubleshoot this, so I'm going to attach to the lower 12 address lines and see if I can figure out where the CPU is, what part of the ROM the CPU is running, because I think it's stuck in an endless loop somewhere in the ROM. So if I can figure out where in the ROM it's running, then I can examine the ROM program and see why it's stuck. I thought I should explain why I'm only capturing the lower 12 bits of the address line when the address is 16 bits. It's because the logic analyzer I have can capture up to 16 different lines, and if I capture all 16 address lines, then it'll be hard to decode the address. Here's the timing diagram of the CPU, and here's where the address is valid. There's kind of a part of the time when this clock signal goes low where the address is invalid, and then when the clock signal comes high again, then the address is valid again. So I kind of need to know where the clock is in order to know when the address is valid. So at the very least, I need to sample the clock and then maybe 15 address lines. But there's a few other things on here that are kind of useful to sample. For example, read-write. It's kind of nice to know when the CPU is reading and writing. And it's also nice to know if there's any IRQs taking place. So this CPU has 3 interrupts. One of them's non-maskable, one of them's regular IRQ, and one of them's fast IRQ. Star Rider does not use the NMI on the CPU board, so I'm going to capture both the IRQ and the fast IRQ. Then I'm going to capture this clock signal, and I'm going to capture read and write, and then I'm going to capture the lower 12 bits of the address. I know where the disk search test is on the ROM, so I'm hoping that I only need the lower 12 bits, and I'll be able to deduce where it's actually running, but we'll find out. Okay, this was quite useful in my opinion, revealing a lot. So remember how I said I wanted to capture the read-write line? Well, you can see here a pattern where it does 2 longer writes than 1 short write, 2 longer writes, 1 short write, 2 longer writes, 1 short line, and so on. So it looks like it's in an endless loop right here, so that should be really easy for me to figure out. Well, hopefully really easy. Also notice how the clock gets stopped here every 63 point. The clock stops every 63.5 microseconds. That's actually something intentionally built into the hardware, where the clock gets paused every field, or sorry, every horizontal line. One horizontal line is 63 microseconds. I haven't yet figured out why they did that, but I know it's intentional, and one of these days I'm going to dig into the schematic enough to figure out why. But for now, I'm going to dig into these repeating writes and try to see if I can figure out where in the ROM it's looping. Okay, I think I figured it out. So I took all these addresses, these 12-bit addresses, and I just put them here into a text file in descending order. And then I went to the ROM program disassembly, and the first address that I wanted to look at was, well, there's these addresses like FF7, FF6, FF5, FF4, and I decided that those were probably not valid addresses because the CPU while it's doing internal work just sets the address lines to random stuff. So I decided those weren't valid. I instead focused on these ones like 48B, 48C, 48D, 48E, 48F, because that looked like a program that was advancing. So since I didn't know what the top 4 bits were, my choices were basically, you know, like F48B, E48B, D48B, 948B. So basically I don't know the top digit. So the first thing I did was I went to 848B and I looked around and I noticed that it stored, at this location it stores something to memory, it stores something else to memory, then it jumps to a subroutine, and the subroutine is at 5E73. And I saw nothing over here like 5 that said E73, so I said, okay, it's probably not 848B. So let's go to 948B. And there is code here. This one also jumps to a subroutine immediately at 4C3. And I looked over here at 4C3 and there's nothing here that looks like 4C3. So then I said, okay, well, let's go all the way to F48B. So I jumped to F48B. Aha, and this looked reasonable because this is a little subroutine that stores something to the watchdog hardware address and then returns. And the watchdog hardware address is equal to C900. And as you can see right here, C900 gets written to. So I said, aha, I figured it out. This 48B refers to F48B, and it is writing to the watchdog. And then right after it writes to the watchdog, it returns to whatever called it. So we go to 492, 493, we have a bunch of these FFFFs that we can ignore. And then it goes to this CA3. So I had to go through the same exercise. Is it FCA3? Let's go to FCA3. There doesn't appear to be any executable code here. How about ECA3? Again, no executable code. How about 9CA3? Again, no executable code. How about 8CA3? Aha! Here's the jump to the watchdog subroutine, and here it loads some of the input off of the StarRider steering mechanism, you know, like the motorcycle handlebars, the acceleration, the brakes, the turbo button. That's what this does right here. And I actually have been having some problems with my inputs that I thought might be related, but I wanted to prove it to myself for sure. So what this does here is it loads the inputs that I just mentioned, acceleration, brake, turbo, and then it isolates bit number 6 right here, which according to my notes is the turbo button. And if the turbo button is clear, then it just loops in an endless loop. And if we look over here at what the addresses are doing, it's going to CA3, CA4, CA5, CA6, 7, 8, 9, and then it starts over at CA0. And as you can see, that's exactly what it does here. It loops back to CA8, CA0, and just, you know, endless loop, because this turbo button is coming back clear. And so the way to fix that is I have to fix my input so turbo is not being held. I have no idea why they designed the program to just hang when the turbo button is being pressed, but that's what they did. And actually, let's see if it says anything about turbo here. Use turbo to advance, brake, backspace. So apparently they do expect you to use turbo, but apparently if you hold turbo down, it just waits until you release it. Or maybe, I'm pretty sure that having turbo coming back as clear means it thinks the button's being held down. So I just need to fix my inputs on my the CPU board so the turbo button's not being stuck on the whole time, and hopefully that will fix the disk search. Okay, I got really sick of having input problems with StarRider, so I just made a custom PCB to take care of this problem. It's got a AVR microcontroller on it and a bunch of outputs that go to this spot on the board, this spot on the board, and this spot on the board. And this was like really rushed job, so I have like, you know, wire sticking out of here, but as long as it works, I don't care. Like, this is I'm just trying to get the inputs working so I can get Dexter working, and I need the inputs to run a disk test. So this is actually pretty cool because this board feeds into this board, which is an FPGA development board, and that is run by controlled by a desktop app, which is controlled by this Xbox 360 controller, wireless controller. So here's my StarRider machine. Watch what happens when I move the joystick. Isn't that cool? Wireless controller controlling StarRider. And like acceleration works. Got a bunch of buttons. There's score reset. Here is left coin, so I can coin up. Let's see what else we got on here. Turbo, brake 1, brake 2, advance. The only one that's not working is slam, and I already figured out what the problem is on the board. The problem is that this inverter needs to be replaced because pin 1 is the input for slam and pin 2 is supposed to invert it, but pin 2 is stuck high, so if I want to get slam working, I need to replace this. But as long as I can run the test without having slam working, then I think that's good enough for me. So yeah, Xbox 60 controller controlling StarRider. How cool is that? So now that I fixed the controller input, this disk test actually works. So I hope you enjoyed the video.